Hey Chemsters, this is Mrs. Vandelay bringing you today's edition of Chemster Video. I didn't do these problems yesterday as the video was kind of running long and I wanted you to have a chance to practice some of this stuff. So hopefully today's video will not take that long. I want to finish up the notes today. It is really a review of everything that we have done. There is no new material today, just more practice, all right? So what I want you to start thinking is that all the problems today are going to be a lot like your test next week, where I give you everything in words. I don't give you the reaction. I don't give you the products. You need to put all of this together. So you need to figure out the formulas correctly. You need to balance it correctly. You need to do the math correctly. So just keep practicing. That's my best advice for some of you who are still struggling. So let's look at problem number 2. This is where we left off yesterday. So it says, what is the percent yield if 4.65 grams of copper is what? Is produced. Copper is not a reactant. Copper is produced. So maybe one of the things you need to be aware of is, read carefully. It says when 1.87 grams of aluminum, I feel like I should say periodic table now, reacts with 5.89 grams of copper 2 sulfate. So what are my reactants? Well, hopefully you probably guessed the first one is aluminum, right? So here's my first reactant, aluminum. And then the other reactant is copper 2 sulfate. So what is the charge of copper? It is +2, right? How do I know that? It's the Roman numeral. What is the charge of sulfate? It's a polyatomic ion. You have to memorize it. So if you are still struggling, because some of your nomenclature quizzes were not that good, you still have to know this. So sulfate is a negative charge. Hey, the charges cancel out. So what is sulfate is SO4. So this is my correct formula of CuSO4. So at this point, you need to ask yourself what kind of reaction it is. Do you remember last week we did 2 labs? One was a single replacement and the other one was a double replacement lab. That was to get you thinking again of this work. Okay, so what kind of reaction? I have an element and an ionic compound. That was really what I was looking for. The last question that I'll hand back to you of the lab. Why is it called a single replacement? You have an element and an ionic compound. It's single placement. So what happens? The elements swap out. So what free element do I get? I make copper. Well, that was kind of a gimme because I was said copper is now produced. So now what's my second reactant? Well, aluminum. What is the charge of aluminum, if you will? Aluminum is always, yikes, +3, right? What is sulfate? Sulfate is -2. By the way, some of you kind of goofed there. Where does your metal always go in these kind of reactions? They always go at the beginning. So put alumina first. So do the charges cancel out? The answer is no. Crisscross, and now you should get Al2SO4. So that is step number 1. Oh, Al2SO4 excuse me. That is the first step of this problem. What's our second step? We need to do what? We need to, yes, balance it. So if I look here, I have 1 aluminum, 2 aluminums. I'll put a 2 here. All right, put a 2 there. I have 1 copper, 1 copper, 1 sulfate. I have 3 sulfates. I have 3 sulfurs. So I'm going to put a 3 here, which means what now? I need to put a 3 here. And I do believe I have now just balanced everything. Okay, so 2 aluminums, 3 coppers, 3 coppers, 3 sulfurs, 3 sulfurs, 12 oxygens, 12 oxygens. That's great. So now what's next? I have to deal with these numbers. I gave you an exact amount of both reactants. I got aluminum and copper 2 sulfate. So they're grams. Yes, periodic table. So I bet you guys are really sad I am not here doing this in person because I am not throwing out any candy right now, am I? So anyway, we need to convert that to moles. So go ahead, pause this, and calculate all your moles. Okay, really do it. Welcome back. Hopefully you did all the math and you're not just going to let me do all the work. So you need to practice this. This is your test coming up, not mine. So this is what I got. Okay, so for aluminum, how many moles? I got 0.0983 moles, so I'll stick that kind of like over here by aluminum. I got 0.0375 moles of copper 2 sulfate, and as you know, you always start with zero products. Okay, so now what? I need to determine which is my limiting reactant. So which one's going to run out first? Well, if you do some quick math, 0.0983, that's close to 0.1. Half of 0.1 is 0.5. 0.5 times 3 is 1.5. Or, yeah, so does that work? Now, I think I'm going to run out of the copper 2 sulfate. If you do a quick math, you'll say, well, 0.03 divided by 3 times 2 is like roughly 0.02. I have plenty. So I'm going to put this as my limiting reactant. Hopefully you saw that. And then I take this divided by 3 times 2, and now I have this. So now I need to fill out the rest. Same number, same coefficient, same number of moles. And then what is 0.0375 divided by 3 times 1? And I get this. So subtract, subtract, add, add. And hopefully you then get, let me scroll this up, oops, there we go, 0.125 moles of aluminum sulfate, 0.30375 moles of that. I have 0 moles of copper 2 sulfate, and I have this much left over. So now what am I supposed to do? Let's go back and reread the problem. What is the percent yield if 4.65 grams of copper? So I need to do something with copper. So let's go ahead and determine how many grams of copper I should or theoretically produce. So why don't you pause this and see what you come up with. All right, how'd you do? Well, this is what I did. I got 2.38 grams is what I should come up with. Okay, that's what I should come up with. So now I need to find the percent yield. Well, percent yield is actual. What did I really make in lab? That's hopefully tomorrow. And what should I make? That's stoichiometry. That's your math. So what's that equal to? Well, what did I tell me? Look at the problem. How much did I really make? 4.65 grams. How much should I have made? Right over here, 2.38 grams. What do you notice? When I multiply that by 100, what kind of percentage is that? Holy cow, that's a huge percentage. So what did we say yesterday? Why would it be so big? It's probably wet. I probably didn't dry it. So in our lab tomorrow, we're going to actually take the mass the next day to let it thoroughly dry. So hopefully we don't have a percent yield that large, okay? Obviously with the percent yield that big, you made some boo-boos. All right, let's try the next one. Okay, so again, think of this as a practice for your test next week, okay? This is how it will look. I give you the reactants in words, but I did give you the octane formula. You need to determine what kind of reaction it is so you can determine the products so then you can balance, so then you can do the math, all right? So if I am burning a hydrocarbon, what kind of reaction is this? Hopefully you said it is combustion. So what are your products every time with combustion? CO2 and H2O. So I'm going to let you do this whole problem yourself. Truly pause this. Don't think you're being sly and just watch me do it. Try it yourself. Remember I said yesterday use a pencil? Have a pencil handy in case you make a mistake. So pause this for as long as it takes you to do the whole thing. It'll probably take you maybe 5 minutes or so. All right, and then come back. Welcome back. Did you do the work or are you just going to watch me do it? Hopefully you did the work. So here is my, whoa, sorry. Don't know what happened there, but okay, here we go. Here is my reaction. I had to put a 2 in front of the octane, 25, 16, 18. And then over here, I figured out how many moles of everything I have. So I go down here. So I have 0.332 moles of octane and 7.31 moles of oxygen. And as it turns out, probably you would have guessed octane, but maybe you're surprised how big this number was. That 2 to 25 does make a big difference. So 0.332 divided by 2 times 25, there you go. And then 0.332 divided by 2 times 16, 0.332 divided by 2 times 18. And so these are your final numbers. So what's next? How many grams of each product we made and how many grams of excess reactant are left over? So obviously these are all moles. So now you need to convert to grams. So here we go. Here's carbon dioxide and multiply by 44.01 to get 117 grams of carbon dioxide. 2.99 times 18.02 is 53.9. And oxygen, notice over here, that's how many grams of oxygen I have remaining is 101. So I didn't use all 234 grams. I only used 100, or I didn't even use, I have left over 101. So gosh, I must have used 133 grams of oxygen there. So hopefully that helps. Now, for your test, you must factor label. If I don't see the factor labeling, you will lose points, okay? So make sure you write down all your units on everything that tells you where to go. So remember, you have moles here, put moles on the bottom. We got grams on top, that's what we want. Okay, this is the final problem. So before we begin, again, think about what's going on. We have magnesium reacting with HCl. What kind of reaction is this? You have an element and a compound. Hopefully you said in your head, single replacement. So what's going to swap out? It's been a little while since we talked about this, but you're going to swap out the magnesium and the hydrogen. Think about where the hydrogen is in the periodic table. It's on the left-hand side with all the other metals. That's swapping out, and magnesium is higher up than HCl, or and so it will flip. So what is your product? Your product is going to be hydrogen and magnesium chloride, but be careful. What will hydrogen be, H or H2? What's the charge of magnesium? What's the charge of chlorine? What's that product formula? Consider all this when you do this problem. Answer the whole thing. You're probably going to take a little bit longer than 5 minutes doing this problem. So truly, pause this, come back. See you soon. Okay, let's see how you did. Well, this is what I did. First of all, notice I have H2. You need that. It's a diatomic molecule. Magnesium chloride, so you need to put a 2 in front. Then I had to go through and determine how many moles of magnesium I have. Wasn't it nice? They gave you 1.65 moles already. So don't be fooled. You didn't have to do factor labeling because they gave you, look at that, moles. So I did magnesium. As it turns out, the HCl is my limiting reactant. So this divided by 2 times 1 is 0.825, 0.825, 0.825. So life got pretty easy there with the 0.825, didn't it? So this is my final result. And now they're asking how many grams of magnesium chloride are made, how many liters of hydrogen, how many grams of the reactant in excess. So I made 78.5 grams of magnesium chloride. I made 18.5 liters of hydrogen. And left over, I have 3.55 grams of magnesium left over. I didn't use it all. So now what? What's the percent yield? Again, actual over theoretical. So if only 5.67 grams of magnesium chloride are made, what's the percent yield? So actual over theoretical. This is what I actually made. This is my, right over here, my theoretical. Divide by 2, or divide by 78.5 times 100%, you only got 7.22%. So you go from one extreme where it's too wet, where you lost a whole bunch of product. So that wasn't too good. You're going to lose some money there. Probably it's down the drain is my guess. But that being said, that's how you do these problems. I hope this was helpful. Now go ahead and check your homework and start the new homework. So have a good day. Oh, don't wait to be great.